Okay, so welcome everyone to my channel and welcome to this video where we will try to once and for all understand everything and anything related to this AI jargons, AI buzzwords, or AI terminology and how all of them are connected with each other. Let's understand that. So as developers, this year has been something very exciting, but at the same time very overwhelming because we have so many words of the year that we have come up with that we have come across. And it's hard. I know it's hard to keep up with every single update that is happening in the AI space. So it's a beautiful yet exciting and overwhelming space. But as you can see on the screen, so all the different terminologies that we hear day in and out, the problem is when we walk into some conference or when we are reading some paper or a blog, and then we are again bombarded with these terms. So unless we have a clear foundation about what are these terms, where they have come from, where they're heading to, how are they connected with each other, it will be very difficult for us to, as developers, to be able to build applications on top of it. So that is my humble attempt to try to break it down in the simplest manner possible so that going forward, 2025 and beyond, going forward, it is easier for every single developer to make sense of what they're dealing with and to build and to be able to build bigger and better applications with this. So without further ado, let's begin. So first of all, I want everyone to take a look at this image that I have on the screen. Because AI is not magic, it's not some superpower that just came out of the fly. It is important for us to understand the historical context, where we started from decades back, and now here we are. It's like the outcome of all the hard work that has gone in for decades. So we wanted machines to simulate human-like intelligence, right? So that is where it all started. So it's not some magic. So we wanted machines very consciously and intentionally, we wanted machines to simulate human-like intelligence. Okay. And that is where the field was developed around artificial intelligence. When that started, that paved way for machine learning, where based on data, like training data sets that you hear, so a lot of data, like lots and lots of data, it was being trained on. Just as we went to schools and then we had textbooks, lots of textbooks, we had to read every single class. Similarly, if you have to think and learn like humans, you have to study. You have to get trained. And that is what paved way for machine learning algorithms on what can be the better way to train the system so that they can also work and act like humans. That again led to a deeper research into how our human brain works. So, not talking about neuroscience, but we know the basic neurons, we have neurons in our brain. So, somehow we wanted systems to mimic that networking, whatever happens inside our brain. So, neural networks came in. So, that was the new buzzword. KNN, classification algorithms, different new buzzwords came into play, which was basically part of deep learning, where we wanted that the machine should be able to simulate how our human brain is working. Why? Because we wanted them to perform some actions which humans can do. Like a very simple example is when you were a kid, did anybody tell you or give you a cheat sheet on how to identify a cat or how to identify a dog? Your parents would have told you, hey, there's a cat or maybe there's a dog. And then iteratively, no matter like how many months and years have gone by, you have seen like thousands of cats and dogs, and then your human brain has picked up the signals, the traits, the patterns that, if these are the traits, these are the traits, then it's a dog or it's a cat. So there is no set rule book that you can say that if then else logic. No, it doesn't work like that. We know things based on iterative recognition of patterns. So that is how our brain are also working, and the same thing we are also training the machines to do. So AI, ML, deep learning. Now when we have put in decades long of hard work, and that led to capable machines who are now able to generate some output for us. So based on all the data it was trained on, based on all the algorithms it has consumed and worked upon, and based on all the understanding of the neural networks, patterns, and everything, now it is capable of doing things which it would normally not do, but it would do it because humans can do these things. So machine is now trying their shot at, trying to write a poetry or generate a blog, which traditionally humans have been doing. And now machines are now trying to do that because it has been trained with so much of data to be able to perform like humans. So this is the very basic understanding which you need to form, that things which machine is good at doing. What machine is good at doing? 2 plus 2. It is able to do mathematical calculations. So traditionally, this is what machines have been trained to do better. Things which are, predictable, things which are iterative, straightforward, rule based. But anything beyond this, humans were able to do it. Drawing an image, it's a work of art. So we have arts and science. So anything work of art, anything which is creative, humans were good at it. But now, based on how humans have been able to be good at art, based on that data, now the machines have been trained and now they are being able to generate image, generate videos, do all sort of creative artistic work which humans have been doing. It is not the question about how perfectly they are able to do and or not. We are not going to that, but we are just saying that it is now trying to do things which humans have been good at doing. And that is very important for you to first understand and not get consumed and overwhelmed with whatever is happening. So before we go further, this is a definition. These are the definitions of everything we have discussed so far. Just hit the pause and just read through it so that your brain is now settled with all the information. So we talked about neural networks, right? Just as human brains have neuron, the circuitry in our brain. So modeling that, then we talked about how deep learning leverages neural networks for learning patterns. Then there is NLP, the field natural language processing, which is basically teaching the machines or the humans to do all of this, to generate all of this, this large language models that we talk about, which are good at generating text. The very basis of it is natural language processing, NLP. Machine learning, the broader field we talked about. Training data. It's like if a human reads a million textbooks, something similar to that we are trying to now simulate with the machines, such that if they are reading, as if they're producing results after having read maybe millions of textbooks, uh, generic textbooks, and not specialized thing. Again, that's a different story altogether. Models. So we're talking about foundational models these days. So these models are nothing but the outcome. So my analogy for that is, for example, we have subjects, multiple subjects, but then growing up, we take up professions. Somebody is good at math, somebody is good at science, somebody is good at both math and science, somebody is good at biology, another at chemistry. So there is specialization. So models are also, a very generalistic simulation of that analogy. I would say that we have different models which are capable of doing different bunch of different things. So we use XYZ model for, let's say, image generation, or maybe some other model which is good at writing social media copies. So we use different models. It's all about choosing a specialization, like we do in day-to-day world. So that is where models come in. We have algorithms, of course, pattern recognition. We just talked about, just as humans do iterative pattern recognition over the years to understand. Similarly, AI systems have also been doing that. And once it does the recognition, now it is time for it to do the prediction. Prediction of the next word. That is what the foundation of LLMs are, right? It is good at predicting the next word or the next token, rather. And inference is English word which just means to infer or to conclude for some from something. So based on what it has seen and learned. So based on just as humans do that, based on the past patterns of a certain person, we try to deduce or conclude that this person may not be a good person, or a bad person for me, or whatever, those kind of deductions and conclusions we make as humans. So that is what machine is also trying to do, think, learn, act like humans. So yeah, I mean, all in all, a small set of prerequisite terminology which you have to understand, because these are something not new. What we are going to connect the dots about is about the new terms, the new buzzwords, but these things have been there since really long, like for many decades, I would say. So these are not new terms. So it's very important for you to understand these terms first, before we go further into RAG and MCP and embeddings and vector databases. So this is like the four-phase journey map, which I was talking about. How actually all the buzzwords or the jargons that we hear of actually connect with each other. They don't work in silos, they don't work independently. All of them are leading to something. So, first is about learning, then search, then the prompts, and finally the application. So, let me break it down even further. I have one more framework which I want to share. So, first of all, AI learns. So, we talked about learning mechanisms. Like just as humans, we go to schools and college to learn things. Similarly, AI is also being trained on data sets, because if you do not learn things, how will you be able to generate? So everything that you're hearing about generating text or generating images, anything generative, is because it has been first trained with so much of big data, worth historical data, training data set. So first, learning has come into play. And when it comes to learning, we all have our own way of learning as humans, right? Some people are good at, creating mind maps and learning. Some people are good at maybe hearing and then they learn. Then there are people who write things down and then they learn. So we have different mechanisms of learning. Or some people are like very good at visualization and, creating memory maps of that sort and learn. So whatever be the case, that has been human pattern of learning. In this case, we have different types of learning algorithms. Many of you might have heard of like supervised learning, unsupervised learning, reinforcement learning. So different algorithms have come up. This video is not about the learning algorithm. That is a different session. And I am not an ML expert who can guide you, but I'm giving a very plain, simple, vanilla developer uh, perspective on what I think that you need to know. So AI has to learn first. It has learned from a lot of data using some algorithm. So it has used a mechanism called algorithm, and it has learned all of these from textbook worth information. So the learning is done. Second comes the search. So that is where you hear terms about knowledge retrieval, knowledge bases, RAG, vector databases, embeddings. So everything, you can think of it like black box. So first black box was about learning. Second black box is about retrieval or the search. Like we go to exams, we cram the textbooks, we go to exams, and now we are retrieving whatever we learned from our brain onto the paper. So we are supposed to retrieve information, whatever we have learned. Third, prompts, the world of prompt engineering, context engineering, whatever be the case. So now we have crammed 10, 15 chapters last night before going to exam. And we have so much to retrieve from the brain. But what do we retrieve? We know a lot of things. You ask me questions, I'll be able to retrieve it. So in the third phase, unless you ask me a question, I will not be able to retrieve information. Similarly, users have to prompt the model that, hey, tell me what is the capital of India. And then it is going to retrieve that information from its brain, from its storage, okay, from its vector databases. So now you see how the dots or these black boxes are kind of connecting with each other. We know the algorithms. Now we know that this is where the retrieval comes in because it has learned, so it has to now retrieve the information. We crammed our textbooks for exams, and now we have to retrieve information. But to retrieve information, we also need a structured question. So that comes in the form of prompts. Now, again, when we enter the world of prompts, there's a huge, a bunch of things starting from types of prompting techniques, zero shot prompting and short prompting. Then there are guardrails which have come in. So the world of prompt engineering is a different thing, but consider all of this as black box, like I'm saying. First learning, then retrieval, and now you're being asked questions. You have to give out meaningful retrieval of information. So that is done. Great. So now we are seeing, hey, our AI is great. It is now able to retrieve whatever I'm asking for. But I cannot ask random questions always that, hey, tell me a joke or tell me the capital of a city all the time. We need some meaningful business value out of it, which means that we go to school and college, we get a degree that, hey, tick mark. Yeah, now you're ready. You're ready for the real world. So then we go for exam placements, right? Interviews, where we are assessed on the basis of whatever we have learned so far that, hey, are you good enough? Are you good enough to join our company and generate some revenue for us? Similarly, now we are evaluating AI on that lines that, hey, are you good enough to help me build a agent which can generate some XYZ dollars for our company? Can you do that? Or can you optimize on some processes and save us some man hours? So things like that. So that is where the application part of it, where we are now leveraging agents. I mean, we are building agents, we are leveraging protocols such as model context protocol, where we are trying to make it uniform across so that everyone can share and exchange values, I mean, exchange information, and build bigger and better applications out of it, which will eventually drive some business value. That is the whole idea behind it. So now we understand that this is the learning to application journey. So we learn, then learning is done, and then you retrieve information. But how will you retrieve unless it is some meaningful retrieval? So we need prompts so that we know what we want to retrieve out of the brain. And then once we know that, yeah, we are able to get right answers, until we are not able to get the right answers, also we keep on prompting, correct? So then when we are confident enough, then we build applications on top of it. Simple. Very, very simple. I would say a breakdown of or a way to interconnect all of these things that we hear about is this. It has to be this. So with that, let me show you this framework which I was talking about, which is kind of going to sum it up, whatever we have discussed. Learn, store, retrieve, apply, and act. So the learning algorithms that we talked about is going to form the foundation of the models. And then whatever it has learned, it is going to store that. Vector databases is where it is going to store. That is what we discussed. Coming to retrieval, the way it does is doing semantic search on the knowledge basis, and yeah, and then of course, when it is ready to do that, now we prompt it, and now it can actually apply the knowledge that whatever it has been trained upon. And finally, we are now talking about the world of agents, autonomous agents, which can independently, think and act, take decisions, do things on our behalf. So I think this is going to sum things up, and is going to nicely help you connect the dots, so that now when you go for any conference or if you're reading anything about AI, you are super clear about what is connecting what, no matter what is the new thing that comes up in this space. I'm sure you'll be able to connect the dots nicely now, and don't get overwhelmed. And I have put together a blog. There are two blogs which I've written. I'm going to link it down below. Uh, if you want to take some more time to take notes, read through the blogs, I would say, and nicely internalize the concepts. And let me know in the comments what kind of other videos you are looking for. And I'll try to put together some more videos on this topic as well. So yeah, I think I hope you have enjoyed this. I hope you have got some value out of this. And this is another image which I generated, which is also going to help you strengthen the concepts that we just discussed. We start with sowing the seeds. We have untrained model, then slowly we get into training phase, then knowledge retrieval. We do the user, as users we interact, we give prompts, and finally, now we get to the stage where we have autonomous systems taking the actions and capable of learning and acting on the behalf of the humans. So I think this captures the entire flow, and yeah, looking forward to your comments in the video, and I hope again that you guys have learned something new and got some value out of it. Yeah. So on that note, thank you so much for watching today's video. We'll see you again.